Hello class, this is the part 2 video for section 11.1, and for this section we'll go through these learning objectives. We'll solve system of three equations containing three variables. We'll determine whether the system is inconsistent and has no solution, or it is dependent and has infinitely many solutions. Okay. Now, as we said earlier on, for a two system, okay, there are three possible solutions that you can get. You can get exactly one solution. That means the system is consistent with independent equations, or has no solution with it's inconsistent, so it has no solution, or it has infinitely many solutions. That means it is consistent with dependent what equations. Okay. And of course, these are the diagrams. It is the first one has one solution. Okay, it has one solution. It is consistent, and it has one solution. And this is it has infinitely number of solutions. Okay, and then this parallel is inconsistent, so has what? No solution. All right. So let's take example. That would be example 8 for this section. We have three equations in the system. Says that x minus 2x plus 3z equals 7, 2x plus y plus z equals 4, negative 3x plus 2y minus 2z equals negative 10. So there are three equations. Okay, we can use the method of substitution or elimination, but we're going to stick to the method of substitution. Sorry, elimination. That is much easier, and as I've treated in this one. So unless sometimes it is easier to do the substitution, which doesn't matter. So for this presentation, I'm just going to use the system, the method of what? Elimination. Okay, and what do we do? Okay, for the system of three that we attempt to eliminate one variable at a time using pairs of equations until an equation with a single variable what remains. Okay, so our strategy is to solving this system will be to use, say, equation 1, and we compare to equation 2 and eliminate x, or we can eliminate y, we eliminate what? Z, depending on which one is easier. So we compare equations 1 and 2 and eliminate what? X from it, and compare equations 1 and 3 and eliminate x, so that it will result into two equations and two variables. Okay, or we can say, let us eliminate y. So we'll use equation 1 and equation 2, eliminate y, and also equation 1 again and equation 3 and eliminate y. And then we'll get two equations, and then we use the approach that we have learned before. Okay, so our goal in this for this question is what? To eliminate y from all the equations. Okay, so first I will compare equations 1 and 2 and then eliminate y. Now if I look at y, okay, it has what? Because it's easier, because it has what? Additive inverses. So it has negative and positive. Therefore, if I multiply equation 2 by 2, I'm going to have for 2y, and so when I add, it's going to go away. So what happens that this equation remains the same. It becomes what? X minus 2y. Okay, x minus 2y, x minus 2y, then plus 3z equals what? 7. All right, and then when you multiply this by 2, you get what? 4x plus 2y, and then plus what? 2z equals 8. So we add them. Okay, we give me 5x, okay, plus what? 0 plus what? 5z equals what? 15. Okay, we'll call this equation 4. Okay, we'll call that equation 4. So basically we have what? 5x plus 5z equal to what 15, which we are calling equation 4. Then also we use equation 1 and equation 3. Okay, we compare them and eliminate y from it. Now, as we can see, this is equation 1. We have 2 minus 2y, and then we have positive y. So basically, we're going to add these two equations. So we just add them like that. Okay, when I add them, I don't need to multiply anything, any equation by any non-zero constant, because if I add them straight away, the y will go away. Now, when I add, I get what? Minus 2x, okay, and then plus what? Z is equal to what? Negative 3. Okay, so we'll call this equation what? Equation 5. Now you see that now we have two equations in two variables, x and z. So we're going to treat them as two system of equations and then solve for x and z. Then after we finish, we put those two values into equation 1 and solve for y. Okay, so these are our two equations. Now, how do I eliminate what? Eliminate x or z from this? Okay, so we can decide, well, let me maintain the what? I'm going to multiply this equation 2, by negative 5, or I can go and multiply equation 1 by 2 and multiply equation 4 by 2 and equation 5 by positive 5 to eliminate the x. But if I want to eliminate what? Z, then I can do that. All right. So first, we want to multiply this by what? Let's say my negative 5. Okay, these equations remain the same. So you get 5x plus 5z equal to 15. And then this will be, if you multiply by negative 5, this will be what? 10x. And this is minus 5z equal to what? 15. All right, so then we add these two. We add, and this gives me 15, sorry, 15x, that's 0 equals what? 30. Then divide this by 15, and this by what? 15. This is by 15. Okay, so x is equal to what? Is equal to 2. So now, how do I solve? I put in, now what? You substitute, you put x is equal to 2 into which equation? Either 4 or 5. It's to equation 4. So that gives me 5x, okay, sorry, 5x, so that's 5 times what? 2 plus what? 5z equal to what? 15. And this is what? This is 10 plus 5z is equal to what? 15. All right, then when you subtract 10 from both sides, it gives us what? 5z is equal to 5, and therefore z is equal to what? 1. So now we have what? X is equal to 2, and then z is equal to what? 1. Now, knowing these two, we go back and substitute into the equation 1 and solve for y, since we know x and then z. So let's go and do that. So finally, we substitute what? X is equal to 2, z equal to 1 into equation 1. Okay. And what is the equation 1? This is the equation 1. X minus 2y plus what? 3z equal to what? 7. So x is 2, okay, minus 2 times y. Okay, let's do that. I was kind of rushing there. So you have, that is what? 2 minus 2y plus 3 times z, which is 1, equal to 7. And this gives me minus 2y, and then 2 plus 3 is what? Plus 5 is equal to 7. And then you have what? 2y is equal to 2. And so y, so minus y is equal to what? Negative 4, negative 1. Okay, y is equal to negative 1. So if you have this, then what is your solution? Okay, so the solution to the system is what? X is equal to 2, y is equal to negative 1, z is equal to 1. And if you write it as an ordered triple, this is not ordered pair because there are 3 variables, it's ordered triplet. You have for 2 minus 1 and 1. Let's be a solution. And I will just leave you to check the what? To just solution for this. Okay. So now remember, we could have eliminated x first from equations 1 and 2, and then 1 and 3, or we could have eliminated was z from that. So now let's go to look at a system that could possibly be inconsistent. So we use the same approach, okay? But this time, if I look at this, the coefficient of the variables, look at the z, look at the z in this one, this is that. This is what? This is -1, this is +1. So it's easier to eliminate what the z instead of what y, or instead of what x, okay? So we go ahead and our strategy is the same. So but first here, we eliminate what z from the two equations first, okay? And how do we do that? So we add equations 1 and 2. This is equations 1 and 2. If I add the z, will go away. All right, so this is my equation 1, equation 2. When I add them, okay, when we add them, this will be what? This is x, okay? This is minus y is equal to what? Is equal to 5. So we get one equation there. Well, this is what we call the equation what? Equation 4. All right, then we look at you compare the equations 1 and equation what? Equation 3. Now it's both negative, so we're going to multiply one of them by negative and eliminate what? Eliminate the z. Okay. So then we're going to add what equations, or it is even easier. Let's go back. Okay. Since I'm using, if I want to use equation 1 and 2, then I need to multiply. But if I look at equation 2, right, and equation 3, if I add these two, so there, this is my equation 2 is my what? My base now. So I compare equation 2 and 1 and equation 2 and 3 because it is easier to eliminate. Or I could have what? Use the 1 and 2 and 1 and 3, but it doesn't matter which one. So here we use equations 2 and 3. When we add these two, okay, what do we get? If you add them, okay, we have what? If you add, you get 2x minus 2y equal to what? Equal to 6. So I have equation 5. So I have this, put them together, I have these two equations. So then, now as we've done before, now we want to solve for x and then what? X and z. All right. Now, before even we go further, look at equation 4 carefully and look at equation. It seems, look at this left-hand side. It seems we multiplied equation 4 by 2, but 5 is not equal to what? That should have been 10, but it is what? It is 6. So that means that this is inconsistent. Okay, before you can even try to solve these two equations, right? But let us assume that we can see that. So let's continue with the solution. Now we're going to treat this as two equations containing two variables. All right. So how do I first of all solve for this? Well, we're going to multiply equation 4 by -2. Now, if you multiply this by -2, if you multiply this by -2, you have a minus 2x plus 2y equal to -10. And this is what? 2x minus 2y is equal to 6. All right. So when we add them, okay, let's see what happens. If you add them, this will be 0 plus what? Plus 0. And this is equal to what? 4. So the -4. So we have 0 is equal to -4, which is what? Inconsistent. All right. Which is false, right? It is false. So it is inconsistent. It has no solution. Okay. So we say that the system has no solution. Therefore, the system is what? Inconsistent. Why? Because 0 cannot equal to what? -4. Okay. Then let's consider a dependent solution, possibly. Same approach. All right. I can eliminate maybe the z because I have this. Let's eliminate z first because I have what? Positive 2z and a negative 2z and then negative 4z. So if I compare 1 and 2, I can eliminate what? Z from the system. Okay, so our plan is to eliminate z from equations 2 and then 3 and add equations what? 1 and 2. All right, so first let's add equations 1 and 2. Okay, when we add them, we have what? This would be 2x minus 3y equals what? Equal to 5. So that gives us that equation. That will be our equation 4. And then we compare equations 1 and then what? Equation 3. All right, so equation 1 and 3. Now, what do? I look at this equation 1, I multiply it by what? Positive 2. Okay, if I multiply by positive, I get 4z, and this minus z. So when I add it, I get the answer. So let's multiply that by 2. That gives us 2x, okay, minus 2y plus 4z is equal to 2. And then you got what? Negative 8x plus 11y minus 4z is equal to negative 417. Okay, so I have it there. So let me erase what is there so that you can see it. Okay, so that's why we have that. So now we're going to add them. Okay, when we add these two, all right, this two, okay, you get negative 6x plus what? 9y equal to what? Negative 15. Okay, so this will be my equation 5. The other one is equation 4. So you put them here and let's try to solve this. Okay, so now as we try to solve that, how do we solve this? All right, now I look at equations 3, 4, and 5. Okay, if I look at equations 4 and 5, let me multiply equation 4 by what? By 3. Okay, if I multiply equation 4 by 3, let's multiply equation 4 by what? By 3, and then maintain this equation. That gives me, this is 6x minus 9y equal to what? 15. And then I have what? Minus 6x plus 9y equal to minus what? 15. Okay, now let's add them. Okay, this will be what? This is 0 plus 0 equals 0. So you get 0 equal to 0. And 0 equal to 0 what? It is what? Consistent. Okay, it is consistent and it has what? Infinitely many solution. So this means that it is what? Consistent and to have infinitely what? Many solutions. So let's go to the next. So the original system is equivalent to a system containing the two equations. So the equations are dependent. That's why we got what? 0 equal to 0. And then the system has what? Infinitely many solutions. Okay, so if we solve equation 4 for y, okay, let's go back. Equation 4 for y, we have what? Equation, it was 2x minus 3y equal to what? Equal to 5. So if you solve that equation for y, we get what? This equation. Okay, we get this equation. And because we have what? It was 2x minus 3y equal to 5. All right, and then if we subtract 2x from both sides, you have a minus 3y equal to minus 2x. Okay, and then let's go back. Let me check the equation carefully. It's a 2x, yeah, minus 3y equals that. And then this is plus what? Plus 5. And then if you divide both sides by negative 3, okay, if you divide both sides by negative 3, you have what? Negative 3 -3, and then -3. So that gives me y is equal to 2 over 3x minus 5 over what? Over 3. That's why I got this. Okay. So what we do is that now the expression, this expression, we want to substitute that into equation 1, okay, to determine z in terms of what? In terms of x. So now we have y in terms of what? In terms of x. So I need to solve one of the equations when I know y as that and solve the z in terms of what? X. And that's what we do next. So this is equation 1. And then what is y? As we found it there, it is what? 2 over 3x minus 5 over 3 plus. So that the equation becomes x minus the y, which is that expression, plus what? 2z equal to 1. Okay, so we can remove the parentheses. All right, we have for x minus 2 over 3, x, sorry, yes, plus 5 over 3 plus 2z equal to 1. Now I can multiply by what? Multiply by the LCM, which in this case is what? Is 3. So this will be 3x, okay, minus 3 times 2 over 3x, okay, plus 3 times 5 over 3, then plus 3 times 2z equal to 3 times 1. Okay, now that gives us 3x. The 3's will cancel. That is minus 2x. This 3 will cancel by the LCM. That's a plus what? Plus 5. Then plus 6z equal to what? 3. And 3x minus 2s is what? Is x plus what? 5 plus 6z equal to what? 3. Okay, so that gives us what? X plus what? 6z is equal to 5 minus 3 minus 5 is what? -2. Okay, so then we are solving for z. All right, remember we're solving for z. Okay, so we move x to the other side, get what? 6z is equal to what? Minus x minus what? 2. Then divide both sides by 6. Okay, which is the same as what? Minus 1 over 6 x minus what? 1/3. Okay, so we have the z is equal to -1 over 6 x minus what? 1/3. Minus 1/3. Okay, so then we can have we have y in terms of x, we have z in terms of x. So our solution becomes like this. So we write the solution as what? Y is equal to this, and the z is equal to that, where x can be any what? Real number. Okay, this way of writing the solution makes it easier to find the specific what? Solutions. Okay, for example, if x is 0, what do we get? Okay, for x, y, and z. Or we can write an ordered what? Triplet in this form. Okay, that x, y, z is such that x is any real number where y is equal to this and then z is equal to that. So for example, if get a specific solution, if x is equal to 0, you plug x equal to 0, you have this is be what? Minus 5 over 3. Now if x is equal to 0 here, this is minus 1 what? 1/3. So the solution, the ordered triplet will be what? X is 0, y is what? 5 over 3, and then z is what? Minus 1 over what? Over 3. Okay, so with this, we can generate as many of what? Solutions. That's why this is what has infinitely many what? Solutions. So this is the end of this the video, and then we'll see you in class soon. Bye-bye.